Welcome back to my dear friends. I have already introduced you the syllabus about the D.D.R.C.S in the previous lectures. So if you have not still watched that video, please go and watch the video so that you can clearly understand what we are going to read in the series of D.D.R.C.S lectures. So let's start this series of lecture of unit 1. So my dear friends, if you have not subscribed my channel, please go and subscribe it so that you can get the notifications once I upload the next series of a video, and I will continuously provide you the lectures along with the note. So don't worry, I will handle the D.D.R.C.S in clearly manner. So let's start the D.D.R.C.S. So first of all, the importance of D.D.R.C.S in civil engineering area is very essential, because designing of any part of the building structures or any civil structures is very essential for the strength or durability criteria point of view. If you want design the any structure element in the proper manner, the failure takes place easily. Then there is no difference between you and masons. So as an engineer, we must have the proper knowledge on the designing of the structural elements, so that we can design it better with economical. So let's start. The design is nothing but having the proper shape and size of the any structures. The any structures must consist of proper shape and size. If the structures does not give the proper shape and size, the failure may take place easily. So while we designing, the structures must have proper shape. Either it may be the rectangles, it's depend upon the type of the structures which we are going to design. So always keep in mind that the proper shape and size of the structures must be needed and must be in demand to prevent from failure. So in drawing, before we designing any structures in the civil engineering, we must need imaginary lines with the proper dimension of the structures, and a proper dimension must be needed in order to design the any structures in the beneficiary manner. So the design and drawing of reinforced concrete structure. Reinforced concrete structures is nothing but the inserting of the steel bar or reinforcement in the concrete to develop the tensile as well as compressive strength and to withstand it easily. As we know that concrete is nothing but the mixture of cement, sand, aggregate, and we add some properties to enhance its property and to increase its durability depending upon the situations and depending upon the locality. We are not using the all type of admixtures in any locality. The use of the admixtures depend upon the locality and depend upon the various factors. So always keep in mind that admixture कभी भी हम लोग मीन्स लोकेलिटी के आधार पे यूज़ किया जाता है और किस चीज़ के कहाँ पे नीड है. So there are the different types of structure, means there are different types of admixtures we have already studied about and its uses. So reinforcement is nothing but the inserting of the steel bar in the concrete to give the proper tensile as well as compressive strength of the structures. My dear friend, as we know that the concrete is weak in withstanding the tensile stress and good in withstanding the compressive strength. A concrete compressive strength को easily झेल सकता है, but at the same times it cannot withstand the tensile stress. So in order to withstand the tensile strength, we must insert best materials in the world, that is steel, to develop the tensile strength and compressive strength in the equal manner. So we must insert steel in the concrete so that it must give some proper strength and durability of the concrete. So the best reinforcement is steel, because the tensile strength of the steel is high and the bond between steel and concrete is very good. So that we can use the steel in inserting into the concrete. So this is nothing but this is so called RCC, concrete cement, means reinforcement of cement concrete. So reinforcement are usually usually in the form of mild steel or high tensile or high strength deformed steels of bar 6 to 32 mm. So there are different types of bars or having the different diameters. The diameter of the bar depending upon the type of the structures we are designing. So the means diameter of the bar vary from type to type. So where means where the where the minimum diameter is required, where the maximum diameter is required, it's totally depend upon the strength criteria. So that's why we are inserting the steel into the concrete to withstand the both tensile as well as the compressive strength and gives the proper strength and durability of the concrete. This is the reasons of RCC structures and the means inserting of the reinforcement concretes. So let's talk about some of the important properties of concrete. As we know, the material means there are the means certain properties of the concretes which are noted by the designers. So let's see, have a one overlook. The properties of the concretes are assumed to be homogeneous, that while we are manufacturing the concrete, the different types of structural element or different types of element are used, like cement, sand, aggregates we are using to for the manufacturing of the concrete. So that material should be homogeneous and the material should be free from the different kinds of impurities. If the presence of impurities are there, then automatically the strength will be decreases. There is no doubt at all, and we know it very well. So we must be careful while we are manufacturing the or while we are proportioning the means different types of structural material to for the manufacturing of the concrete. Similarly, that is characteristic strength. So characteristic strength is nothing but the compressive strength of Q 150 mm at 28 days, which is expressed in Newton per mm square, and we already know. So characteristic strength is nothing but the compressive strength of the cube at 28 days we are already testing, which is expressed in Newton per mm square. So my dear friends, in market there are different grade of the concrete are available. So and the different grades of concrete have different uses. So similarly, from M5 to M10 means here I have written that from M10 to M20, these are the grade of concrete from M10, M15, M20. These are used for the ordinary purpose, means these are known as ordinary concrete, which is used for the ordinary purpose, means where the high strength requirement is not mandatory. So these type of concrete are used in local area where the high strength is not required. Similarly, M25 to M55 means M25, M30, M35, M40 to M55. These are the standard type of concrete, and generally in the construction of the slabs we are generally using M20 or M25. It depends upon the uses of buildings, means how frequently the use of building is going on. As we know, the design of the residential building is different from the design of the any hotels or any prototype structures. So the grade of the concrete increases as the requirement of the load is required. So where the load required is high, the high grade of concrete are used. इन हम लोग जब घर बनाते हैं तो जो रेसिडेंशियल बिल्डिंग होता है मैक्सिमम उसमें M20 लेके M20 ग्रेड का दैट इज 1:1.5:3 रेशियो लेके हम लोग कंस्ट्रक्ट किया जाता है. सो दीज आर द स्टैंडर्ड type of concrete. Similarly, M60 to M80, these are high strength concrete. It is not used in the ordinary purpose. These are used for the high strength where the high strength is requires. See, the content of the cement in this type of grade of the concrete is high, so that their strength is and their bonding strength is very high. So M60 to M80 are the high strength type of the concrete. In lab, some of ultra high strength concretes are developed, that is M55, which are used for the construction of the some big bridges. So there is no doubt that in lab we means high ultra high strength, that is M500 is also produced, and M25 is also has been used for the construction of the some of the big bridges. So these are all about the characteristic strength of the concrete. So let's have some overlook, that is the minimum grade of concretes and which are where it can be suitable for using purpose. My dear friends, M20, I have already told you that while we are constructing house, generally M20 grade of concrete are used. That is, in the mild type of climate, we are using M20 grades. As when the exposure of the climates are increasing, either too hot or too cold, then we have to increase the grade of the concrete. Means the grade of the concretes depend upon the locality of the area. Means where the place where the climate is too severe, means very severe, then we must have to increase the grade of the concrete, that M35 we have to use. So we must have to remember all those things as a civil engineers. So if you know all these things, then it will be very beneficial. So means where we are living, what type of climate is here, so it's totally depend upon the type of the weather and type of the climate. So in the extreme conditions, we use M40 grade of concrete, so that the strength of this type of concrete is very high. So let's see the next properties, that is stress strain relationship. My dear friend, as we know that Young's modulus is directly proportional to stress, that is E is equal to sigma by strain, that is stress by strain. So Young's modulus is directly proportional to strain. If the concrete is having more Young's modulus, then concrete is having more stress. The concrete having more stress are more dense and have more compacted, means it is very difficult to deform such type of concrete. So we can see that from the graph, that is y-axis represent compressive stress, at the same time x-axis represent strain, means deformations. So we can see that the concrete having high compressive stress, that the concrete having high stress, it cannot be easily deformed. This is so because the concrete having high stress are more compacted, having the high modulus of elasticity, and the material having high modulus of elasticity is very difficult to deform, because high modulus of elasticity is having high stiffness. So having high stiffness, it is very difficult to deform, because such type of concrete are highly compacted. So from this curve, stress strain curve, we can see that the concrete having high stress cannot be easily deformed. At the same time, you can see that the concrete having low stress can be easily deformed. So this is all about the stress strain relationship. Here high curves show the higher strength of concrete, means this concrete have higher strength value compared to this concrete. So we can easily conclude that from here. If you have any doubt regarding all those things, please put in comments so that I can understand and I will clear your doubt without any hesitation. So please comment if you have any doubt. So let's go another. Here tensile strength. A designer must be used the following expressions. Here the designers have used these expression, that FCK is equal to 0.7 into root under FCK, that these expressions are used for the design of tensile strength of the concrete, where we know FCK is nothing but the characteristic strength or the compressive strength of the concrete. Similarly, fifth properties of the concrete are modulus of elasticity. Modulus of elasticity can be calculated by, that is EC is equal to 500 root under FCK as per IS 456. Similarly, Poisson's ratio. The value of Poisson's ratio are different for high strength concrete and the weak strength concrete. So this point must be remembered, that the Poisson's ratio value for high strength concrete is 0.1, at the same time for the low strength concrete is 0.2. So these type of questions can be asked in some of the competitive exam, that what is the Poisson's ratio value for the high strength type of concrete. So we must have to know that 0.1, at the same time for weak 0.2, and it is taken as 0.15 for the strength and 0. So this is the average value, means 0.15 can be taken in some of the designing steps. Similarly, 0.2 for the serviceability calculations. So the seventh term is shrinkage. Now we'll talk about the shrinkage. As we know, shrinkage is nothing but the decrease in volume of the concrete, and this happens because of the many reasons, because of the temperature, because of the water content in the cement. There are the many reasons behind it. So this is one of the also important properties, and in order to take the average approximate value of the shrinkage, a strain may be taken as 0.0003. There the total amount of shrinkage in concrete depend upon the various factors. As I have told you that it may be water cement represent at the time of casting. So the shrinkage total shrinkage value while designing must be taken as 0.003. These are the properties of the concrete, so we must have to remember all these things. Similarly, creep, we'll talk about now. The creep totally depend upon the time period. Creep is nothing but the increase in strain, at the same time stress is constant with the time period. जब टाइम बढ़ता जाता है तो स्ट्रेस जो होता है वो constant रहता है, लेकिन at the same time strain changes, means strain increases with the time. So I have mentioned some of the value of aging of loading and the means creep coefficients. At 7 days the creep coefficient value may be 2.2, while the days increases the creep coefficient means decreases. So means it depend upon the time. The deformations takes place more with the time, at the same time stress remain constant. So these are the properties of the concrete. So I have already introduced you some of important properties of concrete, that is stress strain relationship, tensile strength, modulus of elasticity, Poisson's ratios, shrinkage, creep, all those things. So let's talk about the some of the important codes of requirement of reinforcement. So we must, these are the properties of, means above we have already discussed about the properties of concrete. So let's have some look, or let's have some gather at the codes of requirement of reinforcement. So codes of requirement, that means the bar which we are using for the construction must be free from any types of means rust or any types of mud, any types of coatings, so that if there is presence of all these things, then automatically the strength will be decreases. So we must aware from all these things while we are using means reinforcement in the constructions. So all the bars should be free from all these things, and at the same time the chemical means some special chemical coating may be provided means to the reinforcement to enhance its property and and to prevent from the weathering attack. So we must have to give some chemical coating to the reinforcements to means prevent from the all these weathering attacks. So the uses of the bar depend upon the means strength, where the requirement of the strength. So there are the different types of there are different diameters of bar available in the market. So generally bar larger than 32 mm are not to be bundled, means the bar having diameter more than 32 are not to be bundled, or the use of the 3 or 4 bundled bar are also permitted in the IS code provision. At the same time, mild steel conforming IS 432, that high strength concrete deforms bars confining to IS 1786, and hard drawn steel fabric confining to IS 1566 may be used as a reinforcement. A structural steel confining to a grade A of IS 200 are also permitted. So these are the codes of requirements of reinforcement details which are permitted in the IS code book. So you can say for the main bar of the steel, same grade should be used as the reinforcement. The bar may be arranged single or in pairs. Bar larger than 32 mm diameter are not to be bundled. So these all the above we have already discussed about the physical properties of concrete and the code requirement of reinforcement. So let's talk about the loading standards. So we know that any structures consist of or having or any structures must conform with the different types of loading standards. It must be either dead load, imposed load, live load, means different types of loading actions are taking place in any type of structures, and the different types of loading depend upon the means locality of the structures where and the location of the structures, type of the structures, shape of the structures. कोई भी जब बिल्डिंग पे लोड लगता है तो जो जब लोड लगता है तो वो बहुत चीज़ पे डिपेंड रहता है, बिल्डिंग का शेप, साइज, बिल्डिंग का डायमेंशंस, कहाँ पे बिल्डिंग है, लोकेशन ऑफ द बिल्डिंग. सो all these things, there are the various types of load acting on the building, and it's depend upon the type of the building and the location where the building is constructed. So let's have some look. This is very very important, keep in mind, and we know all these things. Let's have some brief manner of knowing all these things. So let's talk about the dead load. Dead load is nothing but the self weight. Just keep in mind that dead load is nothing but the self weight or the self load or the permanent load. Means in the building includes the weight of the wall, permanent wall construction like roof, floor, and the column, beams. These are the permanent structures. The weight of its own is nothing but the dead load. Then the dead load is nothing but the self weight of any structures. So the unit weight of various materials used in the building construction are given by IS code 875 part 1 1987. These are the given by the IS code book, and we know that these loads shall be assessed by estimating the quantity of each material and then multiplying with the unit load. Means we must have means the dead load of the, there are different types of materials having the certain value which are fixed by the IS code 875 part 1 1987. So some of the commonly used materials are there. So unit weight of the important building materials are used. This unit weight is very important. So while we are designing, we must have to take this unit weight under the considerations. This is the self weight of the any structures which are used or any materials which are using in the structures. So plain concrete, the unit weight is taken 24 kilonewton per meter cube. Similarly reinforced concrete, this one is plain concrete, only concrete, not the means having no reinforcement inserted. So reinforced concrete is 25 kilonewton per meter cube. Similarly brick masonry, cement plaster is taken as 20 kilonewton per meter cube. Similarly granite stone masonry is 24 kilonewton per meter cube. Asbestos cement sheet is 0.130 kilonewton per meter square. This one is sheet, so that cannot be taken in meter cube, so it is 0.130 kilonewton per meter cube. So the unit weight of commonly used material is very very important. So while we are designing the different types of structures, so this is all about the dead load. The unit weight of dead load is very important. Once go through this one so that you can clearly understand. Similarly imposed load or live load. Here the imposed load is nothing but the live load, means temporary load, like we human being are putting load on any type of structures is nothing but the live load. Means any extra materials like means furniture, chair, like bed, means any temporary structures which can be changing time to time are nothing but the imposed load. So the load which keep changing, so the load which keep on changing time to time is nothing but the imposed load. So these loads are nothing but the persons, weight of movable partition, dust load, loads of furniture, etc. Similarly it is one of the major load in the designs. See, while we are designing any type of structures, we have to consider all those things. What are the means how many types of means what are the different types of unit of load acting on this structure. So while designing any type of structure, we must have to consider all these things. Otherwise there is no difference between you and mason. So mason can easily construct the buildings and you can easily construct the building. So as an engineer we must have to well concept about all these things means what are the requirement of the what are the requirement of the any type of building, what are the strength to be required, what are the means ultimate strength of the different types of structures. So these are the data is generally for the hostel or hotels, means in imposed load we must have to take the load in UDL and in point load, and we as an engineer we know the UDL is acting in uniform distributions load. The example of UDL is like a tractor with full of sand, right? Just we can take the tractor full of sand is nothing but the UDL. At the same time the point load is nothing but the pinpoint standing at a place, means we are giving force at a certain point only, that is nothing but the point load. We can simply assume from that one, means the distributions of the load is equally in UDLs. At the same time in point load the concentration of the load is at the certain point only. So these are the some of the specific load or the some of the imposed loads which is taken by the designers. There are different types of load, so you may contact some of the book. Here I have written some of 5 or 6 the different types. Living rooms and bedrooms, the UDL must be taken 2 kilonewton per meter square, and similarly the point load is 1 kilonewton per 1 kilonewton only, because this is point load which is concentrated at a point only. So these are the different types of area where the where the generation of the force is different, means the generation of the the generation of the force is different or the force generated is different. This is so because the use it totally depend upon the uses, means we are using kitchen more, so there must be the more UDL concentrated. So all these things while we are designing we must have to consider all those things in essential steps. Similarly wind load, as we know while you constructing the long type buildings, means a building which is above 30 meters, always keep in mind below 30 meters it is taken as average, but when once the building is above 30 meters we must have to consider in mind about the wind load, because the consideration of wind is very important. So, lots of failure takes place in the lots of failure takes place due to the wind. So we must have to consider the wind load while designing of the any type of structures. So we know that the force exerted by the horizontal component of the wind is to be considered in the design of the building, means it totally depend upon the velocity of the wind. If the velocity of the wind is high, then the collapse of the building can easily takes place, and it's totally depend upon the size of the building. So the wind load depend upon the velocity of wind and the shape and size of the building. So some of the complete calculations of the wind is given in the IS 875 part 3 in 1987. Here I have given you some design wind pressure formula, that is Pz is equal to 0.6 Vz square, where Vz is nothing but the velocity and the Pz is expressed in Newton per meter square and Vz is expressed in meter per second. The velocity 0.6 Vz square. So these are the design to be taken while calculating the. So here up to the 30 meter the wind pressure is considered to act uniformly. Above 30 meters the wind pressure increases. As the height of the building increases, the wind pressure is also increases. So we must have to keep in mind while designing the building. So we must have considered the wind pressures also while designing any type of structure. So let's see a snow load. See, a snow load totally depend upon the location, right? Means for the building to be located in the regions where the snowfall is likely to fall, this load is to be considered. This is not considered in all the area. This is only considered in the area where the falling of the snow is very common. So the snow load act vertically. It always act vertically on the structures. So and it can be expressed in kilonewton per meter square or Newton per meter square. So it is given in the IS 875 part 4 1987 and deals with the snow load on the roof of the building. Generally snow falling takes place on the roof of the building. So for the building to be located in the regions where the snowfall is likely to be fall, the load is to be considered. Otherwise it may not be considered in every area. This is only considered in the area where the snowfall is likely to fall. So it is the designer have given that S is equal to mu SO, where S is the design snow located on the plane area, and mu is the shape of coefficient, and SO is the ground snowfall. So this is all about the snow load. Snow loads are undertaken in the area where snowfall is very common. Similarly, earthquake force. Earthquake is also a very important criteria of the collapsation or destroying of the building, or collapse takes place due to the earthquake. As we know, earthquake cause the movement of foundation of the structures. When the earthquake takes place, the vibration of the earth takes place. So when the vibration of the earth takes place, the movement of the foundation, so does the superstructures. When the foundation starts moving due to the inertia additions, due to the inertia additional force develop on the superstructures. So the vibrations caused by the earthquake may resolve into the three mutually perpendicular forces, that is usually taken vertical and two horizontal forces. So the earthquake force can be calculated in accordance with IS 1987-202. So if you go forward, there are the different types of earthquake resisting means type of constructions taking place. So one of the common is that while जब भी घर बनाना, तो जब फाउंडेशन मतलब जब हम लोग गड्ढा खोदते हैं, सबसे पहले तो क्या करना, गड्ढा में रिवर सैंड रख देना. This is very practical. What I have seen in every field area, that the engineer must be feeling that they must dig the ground or they excavate the ground. जब गड्ढा खनते हैं उसमें रिवर सैंड 10 mm हाइट तक रख देना, so it may resist in the failure of the building while vibrating. First of all excavation कर लेना, उसमें क्या करना कि 10 mm तक उस excavation में रिवर सैंड डाल देना, उसके बाद PCC करना, उसके बाद जो उसका फॉलो होता है स्टेप्स, उसके बाद जाली बिछाना, उसके बाद जो RCC होता है करना, फिर कॉलम इरेक्ट करना. सो जो while putting river sand into the excavation or into the foundation, it must prevent from the earthquake force. So this means this is the common what we are taking in the consideration. Now one of the most important topic, that is the method of RCC design. As we know, I have already explained you about the designs. So there are different methods to be adopted while designing RCC designs. Some are very familiar, some are not familiar. So from the upcoming lectures, we must be considered that limit state design methods, and we will solve all this numerical based on the limit state design method only. So see, the main methods of RCC design is to give the any structural members of proper size and proper reinforcement. That is, the structures must consist of proper shape and size, and they must have some proper reinforcement, so that they can satisfy their intended life and they have the good lifespan. If any structures does not have proper shape and size, cannot have intended life. So if the structures must have good lifespan, they must have proper shape and size, they must provide appropriate reinforcement, so that the structures being designed will perform satisfactorily during their intended life. So the design of RCC is very important in the terms of strength. So there are different methods of RCC designs grouped together. See, there are two methods, experimental methods and analytical methods. As we know that experimental methods, first talk about, means experimental methods remove the analytical method. As we know that experimental method is superseded the analytical methods, means replace. But however the new materials have been developed, जब कोई भी नया मटेरियल डेवलप होता है, they have been tested and used experimental basis. Once the new material found, they must be tested and then it can be only used. टेस्ट करके ही फिर यूज करना चाहिए. Then once they have been found suitable theoretically method, then they can be optimated or they can be adopted for economize. Then once the material found to be good, then it must be used for the construction purpose. But this experimental method is only for a small type of structures. If the structures are complex model studies or prototype are built, then this method of design is time consuming and cannot be accepted for the design of each and every structures. So जो experimental method होता है is very time consuming for the prototype and means complex model studies. So these methods are generally not adopted. So we must have to adopt analytical method. So in analytical method, we just identification of the failure criteria based on the material and based on the material properties. So in RCC, the design of RCC in analytical methods are working stress method, which is also known as WSM, similarly load factor method and limit state method. So these are the three methods which are commonly used. They are working stress method, load factor method, limit state methods. Dear friend, most of the students know how to solve the problem. Before solving the problem, we must have good knowledge in all these things. Means why we are not using working stress method, why we are generally preferring limit state method. The both means different methods have different view and they have different steps in the calculations of the structural element required or for the designing of the different types of structures. So let's have some look. Working stress method and limit stress method. I have just separate both of them as a difference between. See, working stress method is easy for calculations. Always keep in mind that working stress method is easy for calculations and it is totally based on elastic theory of RCC. It is working stress method is based on elastic theory of RCC. Similarly, limit state method is require more calculation, so it makes sometimes difficult to design. At the same time, material strength are not fully utilized in designing the member of the structures. In working while we are designing any structures by working stress method, the material having strength cannot be fully utilized. जब हम लोग कोई भी डिज़ाइन करते हैं वर्किंग स्ट्रेस मेथड से, देन जो मटेरियल का स्ट्रेंथ होता है वो फुल्ली यूटिलाइज नहीं हो पाता है, ठीक है, वो पार्शियली यूटिलाइज होता होगा या उससे भी कम होता होगा. बट जो लिमिट स्टेट डिज़ाइन मेथड में जब हम लोग कोई मटेरियल को यूज़ करते हैं देन उसका स्ट्रेंथ जो होता है वो फुल्ली यूटिलाइज्ड होता है. सो द मीन्स लिमिट स्टेट डिज़ाइन इज गुड फॉर एनी टाइप ऑफ designing of in type structures because the material strength are fully utilized in this type of designing. Similarly, means it does not give idea about the excess load. Means this type of means limit state design method does not give the idea about the excess load, but it gives the idea about the excess load which the structure can carry. Here in limit state methods, no factor of safety is used for load, but here design load are obtained by multiplying the partially safety factor and the working stress. We know that means factor of safety is equal to ultimate stress by permissible stress. So design load can be easily obtained from there. This means here means this method gives uneconomical design of structure. At the same time, limit state method gives economical design, and this is means working stress method is totally elastic design method, and that one is limit stress method is plastic design method. Here in working stress methods, some of the assumptions are undertaken while designing the any type of structures by working stress method. So in working stress method, all the tensile stress are taken by reinforcement and none by the concrete. These are the assumptions to be undertaken. At any cross section, the plane sections before bending remains plane even after the bending. These are the means assumptions which are taken in working stress method. Similarly, in in that one limit state method. If you talk about the limit state method, this is a comprehensive method, means we can say that it includes all the area, means this is the comprehensive methods which take care of the structures not only for the safety purpose but also for the fitness throughout the period of service of the structures. So eventually limit state methods is better to use rather than using of working stress method. So limit states method is comprehensive types of methods which take care of the safety factors and the fitness of the means structures. So this method is thoroughly explained in the upcoming lectures. Similarly, one more method is which is not generally used in structures, that is load factor method. Here this method gives very economical section, at the same times it leads to excessive deformations, right, means the deformation takes place in these methods by using these methods is very high. So ultimately cracking taking place. This phenomena is more predominant when high strength deformation bars are used. So the researcher, as more and more researchers continued to investigate the problem related with ultimate load method, it was felt instead of repairing this method, then there is a need for the comprehensive method to take care of the design requirement from the strength and other criteria. This gave rise to limit state method and all close replacement of this method by the limit state methods. Later these methods, load unit methods, found to be difficulty and it does not give any accuracy types of value. So the limit states methods means the limit state methods totally superseded these types of methods, and limit states methods are, that's why limit state methods are better to use in any different types of designing of the different types of structures. So always keep in mind that limit state design methods is best for designing purpose, as it gives the high accuracy and it cover comprehensive methods which take care of the structures for all the perspective point of view. So these are the different methods of RCC designs, and we know the difference between it. So in the upcoming generation we will have some numerical problems and we will have more better lectures upcoming. So if you have any doubt, then please write in the comment box so that I can understand and I will clear your doubt. So thank you friend for listening and motivating me to do so, and please don't forget to like my channels and like it, subscribe it. अपना ध्यान रखें, take care, all of you, stay happy, bye bye.